Hello and welcome to section 4 of the Student Machine Learning Coalition course. In this section we'll be discussing Seaborn, one of Python's many libraries. It is similar to NumPy and Pandas, where you basically have custom codes and commands that you can use to create graphs, plots, and many other data visualization tips and tricks. So let's get right into it with the table of contents. Now to start, we're going to be looking at, obviously since Seaborn is a data visualization module, we'll be looking at distribution plots, matrix plots, categorical plots, and regression plots. All of these are types of graphs that you can use when creating reports or when beautifying your code. Next, we'll be going over, in one brief section, how to style and change the grids of your plots. So quickly, let's go over what Seaborn is and why exactly it's so important. So, Seaborn is a module for data visualization and not comprehension or modification. That means Seaborn is used specifically for the purpose of showing data, not changing or modifying it. Seaborn can put data on your graphs, and it's really good for beautifying your machine learning reports that you will eventually make in more advanced projects, or finding out rudimentary trends as you begin a machine learning course, or in this case like a Kaggle competition. When you start a Kaggle competition, you might want to know where to look, and having graphs to determine where exactly trends are pointing to might be a good way to start. So let's start with section 1, which is distribution plots. Now distribution plots have to do with the distribution of data across certain intervals. Take for example this histogram, which shows the distribution of a certain unit across an interval. As you can see, it's distributed more towards the center, while to the sides it seems to be distributed less. Distribution plots are very basic and rudimentary, and they're the majority of what you usually know already. Let's start with the simple one, SNS displot. This might be the most basic and important graph when it comes to Seaborn. This is because it'll show you exactly what you need to know, and is perhaps a culmination of all the basics. A KDE line, as you can see this blue line here, a histogram which shows you the basic counts for, say example, this variable total bill, and it also shows you just the general distribution of values in a certain series. The syntax for this is sns.displot parentheses data. Now a thing I forgot to mention, but I'll mention now, is that when it comes to Seaborn, you usually import it as import Seaborn as SNS. Like how Pandas is import as PD, or NumPy is NP, Seaborn will be SNS. The next type of data graphing thing we'll be looking at is the sns.scatterplot. It creates a scatterplot, which is a rudimentary form of data visualization, and as you can see, creates individual points for each data. Unlike most other graphs, however, it doesn't actually create lines or any trend lines, but you can do that yourself either visually or adding a KDE, which I'll get to in just a bit. The syntax for this specifically is sns.scatterplot data, x, y. One trend that you'll be noticing throughout most Seaborn plots is that they'll have one of three things, or they'll have at least one of these three things: data, x, and y. As you can see for scatterplot, since we're plotting in respect to two variables, namely tip and total bill, we'll need an x and y coordinate to be specified. But sometimes, as you can see in displot, we don't need an x and y. It's because displot is simply graphing in respect to one variable. When it comes to x and y, also make sure to input x equals column name in single or double quotes as a string, and same with y. Because data, or the argument for data, will be the name of a data frame, usually written how you would write a variable. So when you write x and y, the code will automatically access the column names that you specify with the words x equals and with the words y equal. As you can see, the scatterplot shows a clear trend with an increase of total bill, meaning an increase in tip. And these are some of the rudimentary trends that you can figure out just by using these graphs before you start your machine learning endeavors. The next type of plot we'll be looking at is a joint plot. Now a joint plot is a combination of both scatterplots and diskplots, but you can actually make it a combination of whatever you want. The syntax for this will be sns.jointplot x equals, y equals, data equals, and then kind equals. Now for x, y, and data, it's obviously been switched from the order of scatterplot, which is one thing to keep note of. Whenever you're using your code, keep in mind that sometimes x, y, data, they switch order, but usually for the most part, it'll stay in one of these two orders, which will be very easy for you to use later on. The kind value, however, is a new thing, which basically you can mention the kind of data set or kind of graph you want. Take for example this graph. We have the graph in the middle is a scatter plot, but on the outsides it's a dist plot. Using these double quoted examples like scatter or hist, you can change the type of plot on the outsides and insides. I've only given 2 examples here of double quote scatter and quotes hist, but you can honestly do whatever you want. There are lists of names online that you can use if you need a particular type, or you want to use any of the other graphs that we mentioned in the later parts of this video. Next, let's go to one of perhaps the most basic plot that Seaborn provides, and that's the line plot. A line plot, of course, self-explanatory, graphs 2 variables on a 2-dimensional axis and ensures that it looks like a line. It's almost like connecting the points of a scatter plot. So it is as simple as sns.lineplot and then x, y, and data. Now again, x and y are column names while data is the name of a data set. As you can see in this graph, it's used 2 different variables, signal and time point. And in fact, it uses a 3rd variable because it graphs 2 different lines with respect to STIM and Q. This is an example of a line plot, and it also shows you a little shaded region on the outside, which is a sign of trends or variability. Next, we can look at a hist plot. Now, a hist plot is similar to a histogram, and you can tell by the name that it'll be pretty easy to remember exactly when you need to use a hist plot, what kind of syntax it is. So a hist plot's syntax is quite simple. It's just sns.histplot and then you put in data. And usually your data has to be a series. So what you do is you would specify the name of one column specifically. For example, in the tips dataset, you might use tips brackets total bill or tips brackets tip. Now for the hist plot, what it does is it also creates a histogram similar to matplotlib's plt.hist. As you can see in this example, it maps it on relation to two variables, but you can do it with one as well. And it also has different hues and colors that represent different islands. In later videos, we'll be going over exactly how to manipulate and change said hues and colors. Next, let's go to the sns.pairplot. It's another variation of the join plot. However, it shows you this join plot on many other variables and axes. The data frame, or rather the syntax is quite simple. It's sns.pairplot and then you put a data in. In this example, as you can see, there are 4 different columns that it maps, and it creates correlative graphs for all the data in the dataset. Each column has its own entry in the matrix. For example, look at these columns. On the top, bill length mm, bill depth mm, flipper length mm, and body mass in grams. As you can see, these same columns are all on the top and bottom. And what happens is it creates correlative data sets based on these values. Take for example bill length mm at 40. You can look at up and down all this graph and figure out where exactly it's been distributed. On the diagonal, however, it distributes a dist plot, while on the corners it uses scatter plots. This is because the dist plot is in places where you're mapping the same variable, which means you only need one variable to map, and therefore it can't create a scatter plot because a scatter plot simply wouldn't work. It would just be the same values. However, as you can see, for example, in the second graph down on the left, it maps both bill length mm and bill depth mm in their values. Next, let's look at a rug plot. Now, a rug plot is quite small, and you can use it honestly on many graphs. It creates a small little plot of density indicating on the bottom, and as you can see, as this line increases, the density at the bottom of that line also increases because a rug plot creates a density indicator. Now this is great for visuals and looks quite nice, especially added with stuff like the KDE, which I'll get to in a minute, or when you add stuff to like line graphs, as you can see here. Now let's look at the KDE plot. Perhaps, I think, one of the most interesting plots for Seaborn. The syntax for this is sns.kdeplot. Data equals and x equals. Keep in mind that data and x are now 2 separate entities, and they're actually separate from most of the arguments that we've put in. We've put data xy, xy data. The thing about Seaborn plots is that the arguments will sometimes change, but all you have to do is keep in mind and check your errors whenever you make a mistake to see exactly what arguments you need to put in. Now the KDE plot actually adds all the KDE of kernel density estimation plots and adds them up to create a new plot. Now, a kernel density estimation plot is a value of probability density, meaning it uses specific points and creates a standardized probability density graph. These are almost like mini bell curves, but being put onto each point. What then happens is it uses that density and then creates a new graph, adding all the density points together. It looks somewhat representative of the density of the actual values, which is actually quite important and useful because you can actually quantify the amount of values in a certain area. KDE plots are extremely useful also when trying to basically figure out, without saying it in qualitative terms, exactly how many points are in a certain area. Now the second section we'll be going on in this video are matrix plots. Now matrix plots, like the name, basically use a set of squares to create a density plot almost in relation to two different variables. Now the main matrix plot we'll be going over is sns.heatmap. The syntax for this is sns.heatmap and then data. Now this usually visualizes data with two different gradients. As you can see here, it uses a purple gradient and then also creates a key on the side telling you exactly what the density of said data is. Now, there's different ways to use sns.heatmap, and there's actually many ways that you might fail or you might mess up at it. So first, you have to create a correlative data set. Now, a correlative data set is different in the sense that it creates values and it restructures the data set so that it organizes these values together, like December and 1949 only having two values, or 1960 and July only having 600 values per se. So you usually must create a new data set called data.core. You usually create a new data set or replace your old data set with data.core. For value-based heat maps with only using two columns in a data frame, you can create a pivot table. Now a pivot table is quite interesting in the sense that it actually creates like usable data for a heat map, and it will show you the density on the graph itself, or rather on the data frame itself. The syntax for this is dataframe.pivottable, and then in your parentheses you put values, indexes, and then columns. I'll get to this in more detail in the implementation section, but this is quite complicated and the heat maps aren't usually used often, but when they are used, they're quite beautiful to see in machine learning papers and in your Kaggle competition. So that's it for the end of this video. I hope you enjoyed. In this video we covered distribution plots and matrix plots. In the next video we'll be covering categorical plots and grids in style and regression plots. I hope you enjoyed this video, and if you have any questions, refer to the implementation section or feel free to reach out. Thank you.